That's the power of one of these asteroids. 10,000 Hiroshima bombs is the power packed by this piece of real estate a mile across.
Back in 2017, something remarkable happened in space. Oumuamua, a mysteriously interstellar traveler, appeared out of nowhere, boldly gliding through our solar system. Recently, Elon Musk has confirmed that the strange cigar-shaped object has reappeared, and this time it's not alone, as it has been spotted alongside what appear to be other potentially malicious alien spacecraft.
Nothing else in our solar system looks like this.
However, big questions remain. Why is Oumuamua back again? And what does it reveal about the possibility of alien life? In this video, we will explore the secrets behind this mysterious flying object and the shocking reason why it returned to our solar system. On October 19, 2017, deep within the vast expanse of space, a breathtaking revelation captured the attention of astronomers at the Pan-STARRS telescope in Hawaii. Their watchful gaze discovered a shocking phenomenon, a faint blur that will forever change our perspective of the mysteries that await us in the cosmos. This time, it wasn't an ordinary space rock. It was a mysterious object of cosmic proportions, a cigar-shaped object hurtling through the vast expanse of space. What makes this remarkable interstellar intruder, Oumuamua, even more intriguing is its mysterious shape, which sets it apart from any known celestial objects. Traveling at an incredible speed of approximately 320,000 kilometers per hour, it zoomed past the sun, leaving the scientific community puzzled. Could it be a creation of extraterrestrial intelligence, a piece of a destroyed planet, or even worse, a deliberate projectile launched by extraterrestrial superpowers? Elon Musk hinted at hidden secrets within its structure that point to life in distant star systems. Before we uncover the secrets of this mysterious and potentially extraterrestrial visitor, let's first explore what we learned from its first visit. It all started when the University of Hawaii's Pan-STARRS 1 telescope made a groundbreaking discovery. It detected the first interstellar object ever observed in our solar system, Oumuamua. Located near Maui's Haleakala volcano, the Pan-STARRS 1 telescope can identify space rocks, even faint ones like Oumuamua. Originally called 1I/2017 U1, the Pan-STARRS team decided to give it a more poetic name, Oumuamua, which translates to a messenger from afar arriving first, in Hawaiian. Oumuamua entered as a reddish, elongated object closely resembling a rock shaped like a cigar. It stretched up to a quarter-mile in length, which is about 10 times longer than its width. This unique shape surpasses any asteroid or comet observed within our solar system. Scientists speculate that studying Oumuamua's elongated form could provide valuable insights into the formation of other solar systems. According to Matthew Holman, the Minor Planet Center, MPC director in Cambridge, Massachusetts, the composition of Oumuamua is still unknown. However, he mentioned in an interview that the object will likely be made up of more ice than rock. This is because celestial bodies originating from the outer regions of solar systems, where Oumuamua is believed to have come from, tend to have higher ice content and are more prone to being ejected into interstellar space. We can now explain what happened, says Jennifer Bergner, an astronomer at Cornell University, along with her colleague Daryl Seligman. Their modeling reveals that Oumuamua, which could have originated as a regular water-rich comet near a neighboring star, was likely ejected. According to their findings, the comet's water ice could have been converted into hydrogen, comprising up to 30% of its composition, by high-energy cosmic rays emitted by supernovae and other energetic events that permeate the galaxy. As Oumuamua voyaged through interstellar space, this hydrogen would have become trapped within its ice. The observed acceleration of Oumuamua as it approached the Sun can be attributed to the release of the trapped hydrogen. However, due to the much lower mass of molecular hydrogen than carbon monoxide or carbon dioxide typically emitted by comets, it would not have carried enough momentum to drag substantial amounts of dust along with it, thus explaining the absence of a coma or tail. However, figuring out that Oumuamua came from outside our solar system was easy. Its incredible speed made it clear that the Sun's gravity could not contain it. Traveling at a speed of 196,000 miles per hour was 109 times faster than a bullet. Therefore, it was evident that Oumuamua was not a part of our solar system. Initially, scientists were uncertain whether Oumuamua was an asteroid or a comet. The distinction between the two lies in their composition, with comets composed of ice and asteroids rocky. At first, Oumuamua was classified as an asteroid. However, as it passed by the Sun on September 9, 2017, additional measurements indicated slight acceleration, which is a characteristic of comets. This acceleration puzzled scientists, as Oumuamua accelerated more than predicted. When Oumuamua showed up, telescopes all over the world eagerly watched it to gather as much information as they could during its short visit. It was at this point scientists discovered that Oumuamua had been wandering alone through the Milky Way galaxy for hundreds of millions of years before its visit. As Oumuamua left our solar system, it accelerated faster than expected, surpassing the influence of gravity alone. This acceleration was similar to the speed boost that comets get when they move away from the Sun. When a comet's ice evaporates due to solar heat, it propels the now lighter object forward. However, Oumuamua's speed boost and trajectory did not align with scientists' predictions, raising questions about its peculiar path through space. Since its discovery in 2017, scientists have proposed various theories to explain Oumuamua's nature, formation, and high velocity. One hypothesis suggests that it could be composed of solid hydrogen, which transforms into gas as it approaches a star, thereby pushing the object forward. In this scenario, Oumuamua itself would act as a natural ion engine. Another theory proposes that the object may have a more disk-like appearance based on its acceleration away from the Sun. However, many planetary scientists argue that its behavior resembles a comet, a phenomenon commonly observed within our solar system. Radiation pressure is another potential explanation for Oumuamua's acceleration, which is the force exerted by sunlight on an object. The object's density must be extremely low for sunlight to have a significant effect. The unique shape and exceptionally low density of Oumuamua have sparked debates within the scientific community regarding its possible origins. Some individuals have even entertained the intriguing possibility that it is an alien light sail crafted by an intelligent extraterrestrial civilization. However, such claims are met with skepticism, as there likely exists a more plausible explanation. Oumuamua's arrival in our solar system has provided scientists with a wealth of data and numerous puzzles to solve. In October 2018, Dr. Shmuel Bialy and Professor Avi Loeb presented a theory that raised questions about the object's strange acceleration called Oumuamua. After peer review, their study was accepted for publication in the Astrophysical Journal Letters. However, their theory received a mixed response. Based on several lines of evidence, Bialy and Loeb suggested that Oumuamua's unusual characteristics could be explained by its pancake-like shape and highly reflective surface, resembling a light sail. They proposed that its sudden acceleration and deviation from the expected orbit could be attributed to the effect of solar radiation pressure interacting with a light sail. Even the way it entered our solar system resembled an interstellar explorer as it flew by Earth after its closest approach to the Sun. Its orbital dynamics allowed for a close encounter with the only habitable planet in our solar system, resembling what one might expect from an interstellar probe. As you probably would guess, this claim sparked controversy. Some media outlets sensationalized the theory, insinuating that Bialy and Loeb suggested an alien origin for Oumuamua. On the other hand, skeptics dismissed the idea, questioning why a reputable scientist like Professor Loeb would entertain something they deemed unscientific. Despite facing opposition, Professor Loeb stood by his argument and even published a book that delved into his controversial theory and the journey that led him to it. In his book, Loeb takes a more personal and dynamic approach, appealing to the scientific community and the general public to genuinely consider the idea that Oumuamua could be an extraterrestrial messenger. To understand Professor Loeb's book better, let's delve into its contents. After spending years presenting this controversial theory to the scientific and astronomical community, Professor Loeb shares the story behind his idea. The book explores the mystery surrounding Oumuamua and most significantly, encourages readers to seriously consider the possibility of an extraterrestrial encounter. Loeb describes his arguments in more detail, elaborating on the points he made back in 2018. As Oumuamua prepared to depart the solar system, the Hubble Space Telescope captured final images that revealed increased velocity. The most straightforward explanation for this phenomenon was that Oumuamua was releasing material from its surface due to solar heating, a process known as outgassing, which aligns with the characteristics of a comet. However, Bialy and Loeb emphasized that there should have been unmistakable evidence of such activity. Another puzzling aspect was the lack of a tail during Oumuamua's closest approach to the Sun. Moreover, the sudden acceleration couldn't be explained by gravitational forces. If anything, gravity should have been causing it to slow down. Additionally, if Oumuamua had been outgassing, it would have resulted in a rapid change in its spin, but no such violent spin was observed. According to Loeb and Bialy, radiation pressure was the most plausible cause for the increase in velocity. However, if Oumuamua was neither a comet or an asteroid, what could it be? And what could explain all of its peculiar behavior? Scientists were certain that Oumuamua was unlike any object. All attempts to explain its mysterious qualities in natural terms fell short. When the book was written, no single explanation could account for its brightness, shape, and acceleration, while also acknowledging the absence of outgassing. This idea was partly sparked by Professor Loeb's involvement in Project Starshot, a program aimed at developing a spacecraft capable of reaching the Alpha Centauri system within our lifetime. After careful consideration, they realized that using a light sail propelled by a 100-gigawatt laser was the most effective approach to achieve speeds close to the speed of light. They also concluded that the spacecraft could be as small and light as a mobile phone. Thus, the remarkable concept of Starshot, combining a light sail and a Starship spacecraft, took shape. Neil deGrasse Tyson, a renowned American astrophysicist, shares the same enthusiasm for the existence of alien life. However, he advises against hastily attributing unexplained phenomena to aliens. Neil acknowledges that Loeb may not have completed all his homework before presenting his theory. Nevertheless, Neil believes it is understandable considering the limited knowledge available at that time. During an interview on Star Talk, Neil discusses the peculiar nature of the uncertainty surrounding the trajectory of Oumuamua as it passed near the Sun. He emphasizes that if an object's movement cannot be explained solely by gravity, there must be another force at play. Neil suggests that there are alternative explanations, such as the possibility of ice content melting off as Oumuamua approached the Sun. However, he refrains from hastily concluding that it is of extraterrestrial origin. While he does not dismiss the idea completely, Neil prefers not to immediately propose aliens as the primary explanation. On the other hand, Elon Musk has boldly embraced Professor Avi Loeb's remarkable claims, affirming the existence of elusive extraterrestrial civilizations that lie beyond our grasp. In September 2020, the same observatory in Hawaii discovered another intriguing object named 2020 XL5. This newfound interstellar traveler also exhibited similar behavior, propelled by the reflection of sunlight. The sighting of a small space rock marked a significant discovery as the second Earth-Trojan asteroid ever observed. Earth-Trojan asteroids are celestial bodies that share a stable orbit with a planet, revolving around the same host star. While Trojan asteroids have been identified around various planets within our solar system and beyond, only one object, named 2010 TK7, had been previously confirmed to follow a similar path as Earth. Astonishingly, it was later revealed to be a relic of human technology, a rocket booster from a 1966 NASA mission. The object's thin wall and extensive surface area perfectly aligned with the expected characteristics of a light sail. The discovery of 2020 served as a compelling example, strengthening the argument that Oumuamua too could be a technological construct rather than a naturally occurring celestial body. Now, let's find out where exactly Oumuamua is from. Astronomers using the Spitzer Space Telescope made over 30 hours of observations of Oumuamua in the infrared. However, according to Dr. Meach, an American planetary astronomer at the Institute for Astronomy, IFA, of the University of Hawaii, Their attempts to detect infrared signals from the object were unsuccessful. Dr. Meach focused on the thermal infrared range, which detects heat. She explains that they detected nothing, but even non-detections can provide valuable information. From this, they deduced that Oumuamua must be brighter than anticipated if it exhibits comet-like thermal characteristics. Dr. Meach further explains that astronomers can learn a lot about an object's form, size, and composition by measuring its reflectivity, which refers to how much light it reflects. It was always assumed that Oumuamua's reflectivity would be comet-like and very low. However, they found that it was more like 10% reflectivity as opposed to the regular 4% reflectance characteristic of comets. This deviation from expectations suggests that Oumuamua doesn't quite fit the profile of a cometary body. Dr. Meach adds that if one assumes it has extremely different thermal properties on its surface than other comets, it could reconcile with the 4% reflectivity. Additionally, the infrared studies conducted on Oumuamua revealed an absence of detectable outgassing of carbon monoxide or carbon dioxide from the object. This discovery holds significant importance, as Dr. Meach's team had previously entertained the possibility of Oumuamua emitting these gases at levels beyond the detection capabilities of the Spitzer telescope. The absence of such outgassing adds to the growing evidence that Oumuamua is not as cohesive as a regular comet. The peculiar characteristics of Oumuamua may be typical attributes found in objects from other solar systems, considering their extraterrestrial origin. The trajectory of Oumuamua was traced back to before it first entered the solar system by Corin Baylor-Jones of the Max Planck Institute for Astronomy in Germany. Jones compared the path of Oumuamua to the previous positions of 7 million stars tracked by the Gaia spacecraft. This analysis revealed 4 contenders whose paths closely intersected with that of Oumuamua, suggesting they could be the object's potential origin. However, even this discovery presented challenges. The encounter velocities between Oumuamua and these 4-star contenders were relatively high, ranging from 6 to 16 miles per second. Such velocities are not typical for planetesimals, which are construction blocks of planets. Normally, planetesimals would experience lower ejection velocities when interacting with large planets. The observed high velocities in Oumuamua's case indicate that it is a rare object, defying conventional expectations. One possible explanation for the high velocities is if Oumuamua originated in a binary star system. In such a scenario, the observed ejection velocities would be more plausible. However, none of the 4 contenders were known to be binary stars. The upcoming data releases from the Gaia mission may shed more light on the matter, potentially helping astronomers find a more suitable candidate for Oumuamua's home by further studying the motions of neighboring stars. Despite the limited available data, scientists worldwide remain intrigued by the mysteries surrounding Oumuamua. Its peculiar characteristics have sparked various hypotheses, including the possibility that it could be of extraterrestrial origin. In fact, a draft article by a Harvard scientist and the director of the Pentagon's UFO office suggests the possibility of an extraterrestrial mothership in our solar system. According to the study, this hypothetical mothership could be dispatching microscopic probes, referred to as dandelion seeds, to explore the planets within our system. Although not an official Pentagon document, the collaborative draft study between the Pentagon's All-Domain Anomaly Resolution Office and Harvard astronomer Avi Loeb proposes the idea that Oumuamua may be an extraterrestrial spacecraft. Avi Loeb is well known for his research on Oumuamua and had previously suggested that the object could be of extraterrestrial origin. While Oumuamua itself is unrelated to the small interstellar meteor known as IM-2 that caught Loeb's attention, the incident influenced his belief that an artificial interstellar object could release smaller probes during its close encounters with celestial bodies. In a recently published interview with Patrick Bet-David, astronomer Avi Loeb brings attention to the fascinating case of Oumuamua as it has made its way back into our solar system. Loeb delves into the intriguing aspects of Oumuamua and sheds light on the resistance he has encountered within the scientific community regarding the possibility of objects in space being more than just rocks. He argues that some scientists are reluctant to believe in the existence of extraterrestrial technology due to their investment in past knowledge, and a lack of open-mindedness. Loeb emphasizes the peculiar characteristics of Oumuamua that deviate from typical celestial bodies. One of the most striking features is its unexpected discovery, which surprised astronomers. Additionally, Oumuamua's unusual flat shape and extreme variations in reflected sunlight are highly unusual for natural celestial objects. According to Professor Loeb, these features challenge the prevailing assumption that Oumuamua is simply a rocky body and raise the possibility of alien life. The astronomer further discusses a double standard in scientific attitudes towards speculation and investment. He points out that in fields like cosmology, billions of dollars have been invested in experiments searching for phenomena like dark matter and supersymmetry, despite no conclusive evidence being found thus far. These investments are not labeled as wild speculation, but legitimate scientific pursuits. Professor Loeb asserts that the investigation into the potential technological nature of objects like Oumuamua and extraterrestrial intelligence faces significant hurdles due to prevailing skepticism and ridicule, which impede further exploration. He highlights the importance of maintaining an open mind and consistently applying the scientific method, regardless of the phenomenon being studied. Loeb suggests that politics within the scientific community also contribute to the resistance to considering alternative explanations. He criticizes the prevailing mindset that interprets everything in space as rocks, labeling it as the Stone Age of science. This rigid perspective inhibits the exploration of unconventional ideas. It hampers the allocation of federal funding for studying objects of potential technological origin near Earth. Loeb argues that a more inclusive and open-minded approach is necessary to advance scientific knowledge and uncover the truth about cosmic anomalies. The return of this mysterious flying object continues to provoke speculation and intrigue among scientists. Will we ever unravel the true nature of Oumuamua? Only time will tell. Thank you for joining us on this extraordinary journey. Please like, share, and comment. Don't forget to subscribe to get more of these amazing videos.